Okay, so we are moving on to lesson 6. So we're done with proofs. We're going to move on from that, and that's it. We're kind of finished with proofs for the year. So today we're going to look at an area of a sector or the arc length. So what a sector is, it's a portion of a circle that's bound by two radii and an arc. So almost think of it like a pizza slice would be the best example of a sector, and we start kind of from the center because it is formed by two radii. So here we go. This would be an example of a sector. And think of a sector as it's just like a portion of the circle. That's all it is. It's a portion of the circle. So highlighted in yellow is an example of what a sector is, and this highlight and this is really looking like a pizza now, pizza slice. But anyway, highlighted in purple here is an example of what an arc length is. Okay, so arc length of a sector is like a portion of the circumference. It's a portion of the circumference. So think about a circle, a full circle, all the way around is the circumference. This arc length is a portion of the circumference. A sector, the area of a sector, is a portion of the area of the entire circle. And that's pretty much what we're going to deal with today. So we need to kind of think back to some of our formulas that we learned probably in middle school. So here we go. We have a circle, O, shown below. It has a radius of 12 inches, and a central angle is created by two radii, and it's 60 degrees. And this is known as a minor sector. Why do we think this is called a minor sector? So it's a minor sector because it's kind of just the smaller of the two. Because we also have, going around all the way this way, that would be like your major sector. But this here is your minor sector, and we'll just say it's the smaller sector. The shaded region is the smaller one, so we call that the minor one. Just like we did major and minor arcs a couple units ago. Okay, it says determine the circumference and area of circle O. Express your answers in terms of pi n to the nearest hundredth. Okay, we need to think of our formulas. So we need to think of our formulas for circumference. And it's okay if you don't remember it, but circumference is pi times the diameter. The diameter is twice the radius, so we could say circumference equals, 2 pi r, might be another way to say it. Area, and area is pi r squared. Okay, so this is asking us for the circumference in terms of pi, and then we'll also round to the nearest hundredth. So here in this example, our radius of our circle is 12. The radius of the circle is 12. So my circumference, I'll use the radius formula, 2 pi r. So the circumference is 2 times pi times 12. Or we could say our circumference is 24 pi. That's in terms of pi. So if you ever see that phrase, in terms of pi, that's like your exact answer. You can't get any more exact than that. But we'll go ahead and we'll round it. We'll round it to the nearest hundredth. So 24 to get our pi button, second right here. And that's going to be 75.40, 0.39. That will round up to 0.40. So 75.40 to the nearest hundredth. And area of the circle, area is pi r squared, so area equals pi times radius squared. So area equals 144 pi. Again, that's your exact answer. And I guess it would be a unit squared. I don't know what units are here, but it would be units squared technically. And if we want to go ahead and round to the nearest hundredth, so 144 pi would be 452.40. So 452.40. Okay, that's our entire circumference, so that's all the way around the circle. That's our entire area, so that's all of this shaded in. It's everything. Now they're asking us what portion or fraction of the circle's area and circumference are contained in the shaded sector. Well, let's see. We want to know what portion is contained in this shaded sector, what fraction of the circle. This is 60 degrees. Think about a full circle. A full circle is 360 degrees, so it's 60 out of 360, or we could say it's 1/6 of the circle. It's a sixth of the circle. This sector is a sixth of the circle. I can go do 6 more of these. 1, 2, 3, 4, 5, 6, and then that would make the full circle. So it is a sixth of the circle. It says determine the length of AB and the area of the sector AOB in terms of pi and to the nearest tenth. Okay, so let's do the length of arc AB, and then we'll go ahead and we'll do area of sector. Remember, it's 1/6. It's a sixth of the entire thing. So the length of the arc is a sixth of the entire circumference, a sixth of the circumference. So it's 1/6 of 24 pi. So it's a sixth of 24 pi, and that's going to be 4 pi. So the length of that arc is 4 pi. The area of the sector, well, it's a sixth of the entire area, so it's a sixth of 144 pi. So if we want, we can go ahead and use our calculators. We'll do 1/6 times 144. Let's leave out the pi because else it's going to give us a decimal. So it's 24 pi. So the area of the sector is 24 pi. The length of the arc is 4 pi. I just want to bring this down so we can understand exactly what we found. And then we'll kind of move on to some formulas. Okay. So from here to here, the length from here to here is 4 pi. That's the length of that. And 4 pi is approximately 12.57. So approximately 12.57. The area we found, so this shaded region here, is 24 pi units. 24 pi is approximately 75.4. So approximately 75.4. So what I want you to take away with this is that the area of a sector is a fraction, a portion of the entire circle's area, and the length of the arc is a portion or a fraction of the circumference of the circle. So that means that we could basically set up proportions. Since all circles are similar, the following proportions hold true. Central angle over 360 degrees. This would give us the fraction. That gives us the fraction of the circle we're looking at. So an example, the previous one, it was 60 over 360. The fraction of the angle over the entire degrees, fraction of the length of the arc over the entire circle, fraction of the area of the circle over the entire area. So these are the numerators. The numerators are kind of like the portions of the circle, the fractions of the circle. The bottoms, the denominators here, are the entire circle. 360 degrees is a full circle. The circumference is the length of a full circle. The area of a circle is the entire area. So the denominators are the full portions, and the numerators are the pieces of it, the fractions of it. So let's just kind of put in our formulas here. So we're going to use, we'll use 2 pi r, I guess. And the area we'll use pi r squared. So we're going to be using these all throughout here. And it just kind of, and we'll only use 2 at a time. We'll only use 2 of these at a time. We'll never use all 3. So I think it might get a little bit clearer when we look at some examples. So we have a patio in the shape of a circular sector, has a radius of 20 and a central angle of 110. Find the area of the sector. So we are looking for area of the sector, and that means that we are going to use, so I'm going to bring this down. Sorry, give me a second. Okay, so we're looking at these proportions here, and we are going to be working with, most of the time we'll work with this one. And we want to deal with area of the sector, so we're going to work with this one. So let's fill in what we have. The central angle. Oh, I see the central angle here is 110 degrees. So I could put 110 over here over 360 equals, and I'm dealing with this other one, the sector area. Well, that's what I'm trying to find. That's what I'm trying to solve for. So I'm going to put an x there, divided by pi r squared. Area of the circle is pi r squared. So let's see. The radius is 20, so that's going to be pi 20 squared. Okay, that's actually the hardest part, is just setting that up. So now let's simplify this a little bit. Well, we could simplify the fraction if you want. 110 over 360. If you want, you could simplify it to be 11 over 36 equals x over 400 pi. Okay, let's cross multiply. So 36x equals, go over to our calculator, 11 times 400. I don't know why I needed a calculator for that. Okay. And then at this point, we'll divide both sides by 36. And it does ask us to round to the nearest square foot, so we can put this entire thing into the calculator. Let's put it in as we see it, which means let's use that numerator denominator. So alpha y equals numerator denominator. So 4400 pi over 36. Okay, and rounded to the nearest square foot, that's going to be 384. So our final answer is 384 square feet, or feet squared. Okay, let's take a look at another one. I'm going to bring this down again because we're going to use it. We're going to use it every time. So the accompanying diagram shows the path of a cart traveling on a circular track of radius 2.4 meters. The cart starts at point A and stops at point B, moving in a counterclockwise direction. What is the length of minor arc AB over which the cart traveled? So we are trying to find, so here we're trying to find the arc length. We're trying to find the distance that it traveled from A to B. So the distance around the circle, that's going to be arc length. So we're dealing with, in this case, central angle, and this time arc length and circumference. Okay, let's fill in what we have. Our central angle is 165. So that's 165 over 360. We are trying to solve for the arc length. We're trying to find for the distance traveled. So that's x over circumference. Circumference is 2 pi r. So in this case, that's 2 pi, and the radius is 2.4. Okay, what we can do is simplify our fraction. So that 165 over 360, if we want to go ahead and do that, alpha y equals numerator denominator 165 over 360 divided by 360. That just gives us a simplified fraction of 11/24. That might help us out. So 11/24. And that equals x over 2 times pi times 2.4 is 4.8 pi. Okay, we're going to go ahead and cross multiply. So cross multiply. That's 24x equals 11 times 4.8. Is 52.8 pi. And we're going to round to the nearest tenth of a meter, so let's divide both sides by 24. Divide both sides by 24. And let's do alpha y equals, let's put it exactly as we see it. So we see it as 52.8 pi divided by 24. Let's hit enter, and to the nearest tenth would be 6.9. So 6.9 meters. Okay, let's take a look at another one. So I'm bringing this down again. Okay, here they tell us they give us the area of the sector. So we know that the area of the sector is 12 pi inches squared. And we know the radius is 6. Determine and state the central angle. So we're trying to find something different here. We're trying to find the central angle. So central angle is where x is going to be. The proportions that we're using, the fractions that we're using here, would be the central angle in 360 degrees. And we have the area of the sector, so we're going to use the sector area fraction. So let's make our substitutions. We're trying to solve for the central angle. So that's x over 360 equals the area of the sector we know is 12 pi. And we could figure out the area of the circle. Area equals pi r squared. So area equals pi 6 squared. So the area is 36 pi. So over 36 pi. Okay. We could reduce this fraction. So if you want to let your calculator do it, that's fine. But I need you to realize that a pi over a pi cancels out, reduces out, and 12/36 is 1/3. But your calculator will do it for you. So just hit alpha y equals numerator denominator. 12 pi divided by 36 pi will tell us that it's 1/3. So we'll just simplify it to make it a little bit easier. So x over 360 equals 1/3. Okay, we're going to go ahead and cross multiply. 3x equals 360. Divide both sides by 3, divide both sides by 3, and x equals 120 degrees. Okay, I think we'll take maybe a look at one more. Yeah, we'll just take a look at one more. We'll just do 5. So I'm going to bring this down again because we've been using this all throughout the lesson here. They basically want us to find how many miles north of city K is city H along the arc. So I see the phrase arc, I see the word arc, so I know I'm using arc length. I'm trying to find that distance, and I have a central angle, so I'll go ahead and use that. So we're using those two. X is going to be for where arc length is. That's what we're trying to solve for. The central angle is 9. It's 360 degrees. We're trying to solve for the arc length. And the circumference, the formula is 2 pi r. So circumference is 2 times pi times 3,954. Okay, so I'll go ahead and put that in the calculator. Is 7,908 pi. Okay, we could reduce this 9 over 360 if we want to make things a little bit simpler. So alpha y equals 9 over 360. It's going to be 1/40th. So I have 1/40th, that's what 9 over 360 reduces to, equals x over 7908 pi. Let's cross multiply. 7908 pi equals 40x. Divide both sides by 40, divide both sides by 40. So alpha y equals, let's use numerator denominator like we've been using, 7908 pi divided by 40. Let's hit enter. And we want to round to the nearest tenth of a mile. The nearest tenth of a mile, that's going to be 621.1. Okay. All right, so we're going to stop there. We are going to continue with arc length and sector area because it is a little bit of a tougher topic. All right, have a good rest of your day. Bye.